Okay, we're looking at next exercise 5 from the first year core textbook. I'm on question 15, so quite a long one, although each individual part is not worth too many marks. It's an exam question. Okay, so we've got coordinates, points A and B, and we're given their coordinates, and we need, so very familiar. If you've been working through this exercise, we've got to find the equation of the line that goes through A and B. Okay, so quite a nice gentle start. So I'm going to get the gradient through A and B, so that's changing y, so 6 minus 2 over change in x, so 4 minus 12. So just must make sure I'm consistent with the way I'm subtracting. So you could also do 2 minus 6 over 12 minus 4, and that would be absolutely fine. So that is going to be 4 over minus 8. So whichever way around you do it, you should end up with minus a half. Then I'm going to use y minus y1 is m times x minus x1. It doesn't matter which coordinate I use, so I'll use 4, 6. So I've got my gradient of minus a half. I've got my x coordinate of 4, and I've got my y coordinate of 6. So y minus 6 is my gradient times x minus 4. It asks for, it does ask for it in a particular form, and it wants A and B and C to be integers. So first thing I'm going to do is multiply through by that 2. So if I multiply up by 2, and then I'm going to multiply the brackets through by the minus 1. So that will just change the sign of everything. And then add the x over to the left-hand side and minus the 4. Okay, so as long as everything is together on the left-hand side and they're all integers, you're fine. So well, I guess the only alternative really would have been minus x minus 2y plus 16, and that would have been okay. It doesn't say they've got to be positive integers, any of them. Right, okay, so part B. So I can cover up the rest of the question, because obviously to answer part B, you should only need the information they've given you so far, and actually it can stop you getting distracted by anything else they might mention. Okay, so part B only worth 1 mark, and wherever it says write down or state or anything like that, it's normally you've got the information, you've just got to interpret it. So if it's passing through the origin, its y-intercept is 0, so I'll just go straight to y equals mx plus c. So m is minus 2/3, and it's going through the origin, so c is the plus c is 0. So that's why it says write down, just indicate that that's line 2. Should be quite obvious, you'd have thought. And that's why it's only worth 1 mark. Right. Okay, so very familiar stuff they're asking us to do. So find where those two lines intersect. So in fact, I don't need to write them out again. So where those two lines intersect, and I am going to use substitution. And where this one says y, I am going to substitute in minus 2/3 x. There's variations on how you might tackle it. I think that's one of the quicker ways. So the first equation becomes x plus 2, and then for y, I'm substituting in minus 2/3 x. Minus 16 is 0. So let's just tidy that up. So if we multiply out those brackets, that's going to become minus 4/3 x. In fact, tell you what, let's add the 16 over in the same stage. So 1x minus 4/3 x is minus 1/3 x. So if I multiply it up by minus 3, okay, that seems quite big, but I think we'll go with it. I can't see anything daft I've done. Let me just double check. Yeah, okay, I think that's fine. So that's my value of x. So to find y, I'm going to go back to this equation. So y is minus 2/3 of x. Oops, I can't really see that. So minus 2/3 of minus 48. So 1/3 is 16, 2/3 is 32. Okay, and it wants it as coordinates. So the coordinates would be minus 48, 32. Okay, and then part D. Oh, crikey. There's quite a lot to this in there. So show that OA and OC are perpendicular, where O is the origin. Okay, all right. Well, so OA is, so O is the origin, so that's 0, 0, and A is 4, 6. That was given to me in the original question. So the gradient from O to A, so I'm doing change in Y, so 6 minus 0 over change in X, so 4 minus 0, so 6 over 4, or 3 over 2. So that's one of the gradients. And then OC, okay, well, we just worked out C. So then obviously the origin is 0, 0, and C was this answer here. So C is minus 48, 32. The good thing about this is if these don't work out to be perpendicular, then I'll know that I've made a mistake in C. So that's not really a good thing, but at least I'll know. So the gradient of OC is change in Y, so 32 minus 0 over change in X, so 48 minus 0. So 32 over minus 48, so that all cancels by 16 and gives me, just about fit it on the end there, minus 2 over 3. So they are perpendicular, but I must be careful because it says show that, so I just need to clarify how I know. So the gradient of OA times the gradient of OC would be 3 over 2 multiplied by minus 2/3, which gives me minus 1. So therefore, they are perpendicular. You could also write a sentence explaining that one is the negative reciprocal of the other. That would also justify it. Okay, work out the lengths of OA and OC. Okay, yeah, so we're building up to finding an area, aren't we? And then, again, that's quite a nice clue because obviously if I don't end up with a third of root 13, then I know I've gone wrong somewhere. Okay, so I've already forgotten what it was. So length of OA and OC. Okay, so again, just try and write a little bit smaller so we can fit everything on the screen. Okay, so length of OA, so I'm looking here. So that's going to be the distance between O and A. So that's just Pythagoras. So I'll write out the full working. But basically it's going to be 4 minus 0 all squared plus 6 minus 0. So I'm just finding the distance between those two coordinates highlighted in pink. So that is going to be root 16 plus 36. So root 52, obviously you can just stick this all into your calculator. Yeah, so that is, so 52 is 4 times 13. So that becomes 2 root 13. So that's the magnitude of OA, or the length of OA. And then OC, so that's also hopefully going to be come out as a third. So OC is the distance between these two coordinates. So again, Pythagoras, so it's going to be 32 minus 0 squared plus minus, I mean the minus is irrelevant because I'm squaring, but minus 48 minus 0 squared. So that is definitely going into my calculator. So 32 squared plus 48 squared, all square rooted, is 16 root 13. Okay, so as far as I can judge, that's looking pretty good because they are both in terms of root 13. Okay, and then, yeah, we are pretty much there. So hence calculate the area. And it's only 2 marks. So, and obviously hence should mean we can use our previous answers. So I really don't even need this to be to scale because I know, okay, I might as well sketch it to scale. Otherwise I'll spend longer trying to explain what I'm talking about. Okay, so there's my axes. I mean, it's not going to be particularly to scale because the two coordinates are very different to each other. But 4, 6 can be about there, and that was A, I think. And then C was minus 48, 32. So, obviously not to scale, but we'll get the point across. So that was point C. Okay, and what I have shown, and then obviously that's the origin. So what they've been building up to is we've shown that they are perpendicular. So we know we've got a right angle there. That's the triangle they want the area of. We've just worked out that OA is 2 root 13, and OC is 16 root 13. So obviously if they're perpendicular to each other, they're my base and my height. So the area is a half times the base times the height. So what is that going to be? That's going to be 16 times 13. So 208. And it doesn't mention, if it had mentioned sort of exact form, I'd have been a bit worried, because then it should have been in terms of a surd. Yep, I think we're okay. I'm just checking the answer to A. That's what we got.